Okay, this is a one-topic video for section 3.4 for long division. So what we're using is the division algorithm. This is what you kind of learned back in grade school, just didn't have the functions involved. So we're going to have two functions. We're going to have a function that we're going to divide and another function that we're going to be the divisor. We're going to divide in, by. And they're polynomial functions. The degree of f is greater than or equal to the degree of d, and d can't be 0 because you can't divide by 0. When that happens, then when I divide f of x by d of x, okay, I end up getting a quotient and a remainder. So f of x will be equal to the divisor times the quotient, and then plus any remainder that might be there. R is the remainder, and you know you're done when the remainder is equal to 0 or a degree that is less than the degree of d. This is what this is all saying. Okay. Now, why do we need to know long division of polynomials? What's its purpose? Well, part of what we're going to be doing in this unit is in this lesson and in this unit is being able to find the zeros of all polynomial functions, and we want to get to a factoring process. And division is basically factoring. Division can be used as a factoring. To factor a polynomial. And if the remainder is 0, then the polynomial is factored, because if that's 0, then I've taken the function f and written it as a product of two different functions, meaning it's factored. So I'm going to show you an example of what to do as you go through this process, and I'm going to write the steps over here, the guidelines that you want to follow when you do this. So the first one here, I just made this up. I have no clue what the answer is going to be. I'm going to be just as surprised as you. So the first thing, though, is the setup. The setup is very important. If you look at the polynomial here for f of x right here, we can see that the highest exponent is a 3, and we need to look and make sure that it's in proper form, that it's in descending order, all the exponents are in descending order, and so forth, and are there any missing terms? And as we do this, we can see that there is no x term here. We do the same thing for the divisor over here, and we'll notice that the highest exponent is a 2, and again, there's also no x term in here. In the setup, it's important to understand that you have to have all the terms are present when we do long division, or things get out of a line. So what I ask you to do is, you're going to put a 0 times x to whatever power is missing. So this is the one that goes inside the house, just like in grade school. So you're going to have a little house. We put this inside, 3x to the third minus 7x squared. And then because there's no x term, I'm going to put plus 0x. And then plus 14. This keeps everything in a line. Same thing for that divisor that goes on the outside. Here's x squared. And because there's no x term, I'm going to put plus 0x and then plus a 2. This is the setup. So this long division process is very similar, because basically the same process you learned in grade school. It's just you have these variables involved, and that kind of changes it just a bit, but you will see some similarities in what we're doing here to what you did back then. The next step is we can start our division process. For polynomials, you're going to divide the first term of the, by the way, this is the dividend. This is the dividend, and this is the divisor. So the first term of the dividend by the first term of the divisor. So this is the divisor, and this over here is the dividend. The first term here is x squared. The first term here is 3x to the third. What times x squared gives me 3x to the third, or 3x to the third divided by x squared, however you want to look at it. Either way you get, it becomes 3x. Because I get a 3x, I'm going to put it above the x column as a 3x. This is very important to line things up, or you'll end up getting, addition errors and stuff like that because you're adding unlike terms and stuff like that. So once you have that, you put it up above. So right in the proper column above. Okay, so this is what you normally did. You put it divide in, you put a number above. And in grade school, what did we do? We took that number and we multiplied it to the number outside. And we put a number underneath. And that's what we're going to do here. You're going to take 3x and you're going to multiply to every one of these terms and lining them up in the proper column. So 3x times x squared is 3x to the third. 3x times 0 is plus 0x squared. X times x is x squared. 3x times 2 is plus 6x. Okay, so that's what we just did right there. So we're going to multiply this expression to every term in the divisor. Be sure to write under the dividend and line it up properly, like I just did. So what's next? Well, in grade school, when you did this, you subtracted. Well, here we're subtracting polynomials. So I want you to visualize, and I'll just show you what we're having. If I have a 3x plus 1, and then I want to subtract a polynomial that's 2x plus 3, see, I'm subtracting the whole polynomial, which would be in parentheses. Even though you don't see the parentheses here, they're kind of there. And so you would have to distribute this negative sign to get rid of the parentheses. So that's what's going on here. You can't just simply subtract, okay, put a minus sign here and do that. You're going to make sign errors. So what I usually tell people to do is, instead of subtraction, we're going to basically do the distributive property. So what we're going to do is, just remember this little phrase, you're going to draw a line. What line? This line, draw the line. Then you're going to change all the signs, and change the signs. This is you distributing. So now you're distributing. You're going to change all these signs, and I usually exaggerate the sign change, so if I get distracted, I'll know if I did it or not. So minus, minus, minus. See how I made all the different sign changes. And then do what? Instead of subtract, we're going to draw the line, change the signs, and we're just going to add them up. So now I just got to add in columns. This plus a negative 3 is 0. And that should happen because that's what you were trying to accomplish. A negative 7x squared plus 0 is a negative 7x squared. 0 plus a negative 6x is minus 6x. So that's how that works. Once you do that, and you subtracted back in grade school, you brought down the next number. But here, we bring down all remaining terms. Not just the next one, but all remaining terms. So there's only one left here in this example, so we bring it down. And then we repeat as needed. So what times x squared gives me a negative 7x squared? Negative 7. Multiply that to every term out here. Negative 7x squared plus 0x minus 14. Draw the line. Change the signs. See how I make it pretty obvious what I'm doing? And then add these up. So that will be a 0. Negative 6x plus 0 is a negative 6x. And then 14 plus 14 is plus 28. This exponent is smaller than that one, so you are done. This is it. And so the last part here is, how do I write my answer? So you want to write your remainder as a fraction. And it's always plus the remainder. So plus r of x divided by the d of x. Always plus the remainder. Okay? Always add it. Even if the sign is negative, like this right here, it don't matter. It's going to be plus this number. So here's the answer, and this is how you would write it. So let's move this down so you can see a little bit more. Oh, it's not going to do it. I always write answer. Here's your quotient. Then plus, and then in a fraction, negative 6x plus 28. And then down below, I don't need the 0 anymore, so it's going to be x squared plus 2. So this would be your answer right there. And that is long division. Okay? And so I'll post this one as a long division video for 3.4, and then I'm going to make other videos for individual pieces.